In this video we answer the question, what is a giant ionic lattice? If you want to find out more about lattices, you are in completely the wrong place. But if it's a lattice you want to know about, then let's go. So, hopefully you've watched the video on what is an ionic bond. And you will remember that it's the attraction between a positive metal ion and a negative non-metal ion. But the thing is, if we have a positive metal ion and a negative non-metal ion, they won't just attract to one other ion. So think about this sodium ion here. It's positive, so if another negative ion comes along, it's going to attract and form a second ionic bond here. And then if another negative ion comes along, it's also going to attract the positive sodium ion. And guess what? If another negative ion comes along, it will still attract to the positive sodium ion because there's space for it to do so. And in fact, if you think about this in 3 dimensions, another fluorine could come in front, another fluorine could go behind, and you could get lots of fluoride ions, I should say, around the sodium ion. Now, what happens if another positive ion turns up? That's right, it can attract to the negative ions. And so when metals and non-metals bond using ionic bonds, which they always do, you don't just get one positive ion attracting to one negative ion. All the positive ions attract to all the negative ions, and all the negative ions attract to the positive ions, until you've got this huge network of loads and loads of ions. Now, if I take away all the electrons, this is the basic structure that we get. So you can see every negative non-metal ion is next to positive metal ions, and vice versa. And what that means is that when you form ionic substances, they don't just have a couple of ions in them. They're these huge structures that have billions and billions of ions going on in every direction. And even this 3D model here doesn't really represent how many ions you would have in a giant structure. So take salt. If we could zoom right in on sodium chloride, it actually looks like this. They're tiny little perfect cubes, and they're cubes because they're showing the structure of the 3D giant ionic lattice that forms when a metal and a non-metal bond to one another. The next thing that we need to know is what the properties of giant ionic lattices are. But before you do that, quickly make a note of what a giant ionic lattice is, focusing on explaining why when metals bond to non-metals, you don't just get a couple of ions bonding, but loads and loads of ions bond in a huge network or lattice. Don't stop believing.